So I find a lot of students actually hate this problem. This is a word problem, linear systems word problem, and it kind of trips them up. Um, but let me kind of go into it. Maryam has a bottle of 5% acetic acid and a bottle of 10% acetic acid. We have two bottles here. Now, those bottles, let me kind of draw them out here if this helps. I don't know. My drawings are really bad. There's a bottle here, and 5% of the liquid inside of it is acetic acid. There's another bottle. Okay. Oh boy, that's terrible. Okay. There's another bottle. 10% of that bottle's liquid is acetic acid. Okay, so there's more liquid in here than just 5% acetic acid. That's just 5% of the bottle, right? So let's say X is the total amount of liquid in milliliters inside of this bottle. Let's say Y is the total amount of liquid inside this bottle. Again, 10% of it is acetic acid, but the rest, I don't know whatever it is. How much liquid out of each X and Y should I have to make 250 milliliters, of which 8% is acetic acid? We need two equations. One is for the total liquid, and another is just for the acetic acid part. Okay, let's do total liquid. So total liquid, X plus Y, is 250. That's going to be the end mixture, right? So X plus Y is 250. Again, this is acetic acid and everything else. But there's a second equation, and this second equation just focuses on the acetic acid part. So going back to X, 5% of X is acetic acid. Okay, so how do you take 5% of X? You do 0.05X. Done. How do you do 10% of Y? 10% of Y is acetic acid. I go 0.1Y. Now, the end mixture is going to be 8% of 250. 8% of 250 in the end will be acetic acid. So I do 0.08 times 250. What is 0.08 times 250? I believe that's 20. So I have 0.05x plus 0.1y equals 20. This is equation 1 at the top. This is going to be the final form of equation 2. And now I've got two equations, and I can solve. Amazing. Take equation 1 right here. This is a good candidate to use substitution method. So I'm going to isolate for one of the two letters. I'll isolate for x. So let's move y over. So x is going to be 250 minus y. Awesome. Take this x and plug it into the second equation. So I've written everything as is, but I've replaced x with this bracket. This is it. Okay. Distribute 0.05 into this bracket. What would that look like? That would be 12.5 minus 0.05y plus 0.1y equals 20. Beautiful. Let's move on to calculate. So now I can collect these two, right? So those two together are going to make a positive 0.05y. Okay, because it's negative 0.05 plus 0.1, that's positive 0.05. I still have this 12.5. And now I can isolate for y. Subtract both sides by 12.5. Those two cancel. 0.05y equals 20 take away 12.5, 7.5. Divide both sides by 0.05. Y is going to be 150 milliliters. 7.5 divided by a really small number, you're going to get a big number. Y equals 150. So out of the 10% acetic acid solution, right, I need 150 milliliters of it. 150 total, okay? Now, the total amount of liquid, though, I know is 250. 150 of which belongs to the 10%. So how much belongs to X? Let's do this. X plus Y, let's bring down equation 1. X plus Y is 250, Y is 150, so X plus 150 equals 250, right? I just replaced 150 right here. Subtract 150 from both sides. X is going to be 100 milliliters. And this is where you write your therefore statement because you found the answer. The answer is, out of the 5% bottle, take 100 milliliters of it. Out of the Y percent, the 10% bottle, take 150 milliliters of it. You'll get 250 in total, and in the end, 8% will be acetic acid.